Hello again. Hello again. This is the second attempt. On the previous one, due to certain improvisation, I didn't mention that this is Friday the 27th of March 2020. We're in the middle of this lockdown, but it's okay. I think we can continue, and as I mentioned, we reviewed, or at least I tried to review the acronym. I also reviewed or mentioned the three requirements to have a laser beam or a laser effect: the gain medium, the point source, and the cavity. So basically, there are also three requirements to have, three characteristics that the laser beam has. So I would explain them here. Characteristics, yes. But first, I would like to depict or try to draw the basic schematic of any laser. So as a gain medium, we can have, let's say, as I said, maybe one of the rare earths in nature, let's say ytterbium, erbium, praseodymium, neodymium, thulium, even holmium. Yeah, specifically because I am trying to direct this course towards the subject that I work in my research, which is fiber lasers. So that is a gain medium. That is the kind of gain mediums that we use in fibers. So the fiber, that is a piece of glass, it's doped with one of these materials at several concentrations. So the next one, the next requirement is a point source. Yeah. So as I mentioned previously, it could be another laser source, a laser diode, even a fiber laser in a MOPA configuration, master oscillator power amplifier, a high current going through the material, and a high brightness, let's say, beam, which doesn't have to be laser. And last, but obviously not least, one requires two reflective surfaces, yeah, on which the reflection doesn't have to be 100%. And these two surfaces form what we call a cavity. So, for instance, we are in this living room, and my voice is bouncing back and forth from the walls and also from the ceiling and the floor, and this is a cavity. But in this case, this would be an optical cavity on which the produced light would produce resonance after several phenomena that would have to occur. So reflection 1 could be 100%, as I said. Reflection 2 could be different from 100%. And why? Because we need an output, of course, after we produce the beam, after we start pumping the ions, well, creating ions from the gain medium. There will be a point on which we reach what we call threshold, on which, as we would see later on, the gain is higher than the losses in the cavity. Then amplified spontaneous emission stops from being generated, and then all the energy is converted into a laser beam. So let's go into the three main characteristics of a laser beam. The first one is monochromaticity. So a laser beam is monochromatic, which means that it has to have certain spectrum of less than a few nanometers, which means the center wavelength has a peak, but then it has some width, but it's basically monochromatic. The second one is divergence. So the divergence of a laser beam is theoretically zero. So zero divergence, which means that as soon as from the aperture of the output of any laser that you may have, the delta theta, which is theta is the angle on which the divergence is occurring with respect to the space or length that is describing, should tend or should be as close as zero as possible. Of course, this is only theoretical and it almost never happens. All laser beams have some divergence. And the third one is coherence. So you can imagine that when you are in your swimming pool or in the sea, you see waves. So when the waves from any disturbance have a maximum, yeah, all waves have a maximum. And when the wave have a minimum, all waves have a minimum. So when this occurs, we can say that the waves from a laser, from a beam are in synchrony, and that is the concept of coherence. So as I said, when these three characteristics from any laser beam are met, then we have a laser. We have a laser beam. So let's continue on next session, and I will explain a bit more, and I will go into depth into the concepts of the laser phenomena. In fact, thank you.